So if I were to say how many inches is 10 centimeters? So this, when setting it up, we start with what we're given, 10 centimeters. We are looking for a conversion factor that will go from centimeters to inches. So I'm going to put in, I need to cancel centimeters out. So I put centimeters on the bottom and inches on the top, so that centimeters cancel each other out. I know that 1 inch is equal to 2.54 centimeters. So 1 inch for 2.54 centimeters. Then I multiply the top and divide by the bottom. So that would be 10 divided by 2.54. And that's equal 3.937. Centimeters cancel each other out. So there's one on the top, one on the bottom, and I'm left with inches. So converting between moles and grams. So H2O. So let's say how many grams are in 10 moles of H2O or water. This is another way of saying how much does 10 moles of water weigh? This is the exact same question. So we start with what we're given. 10 moles. And we need a conversion factor of mole to gram. So conversion factor of mole to gram. I know that molar mass gives us that conversion factor. So hydrogen, so there are 2 hydrogen and 1 oxygen. So I'm going to round because I'm doing mental math. So that'd be 2 times 1.00794 plus 1 times 1 times 15.9994. This is from memory. Yes. Yes. And this tells you it's 18.01528. And molar mass is grams per mole. So we have 18.01528 grams per 1 mole. So I put this number with the grams over 1 mole. And so it would be 10 times this, so that would be equal to 180.1528 grams, because moles cancel out, giving me only grams. Yes, so how many moles are in 55 grams of water. So we're starting with 55 grams. I know that there's a conversion factor of grams to moles. So this is a conversion factor that tells you the ratio between grams and moles. So I can go ahead and convert this into moles. I have grams on top. So to cancel out that grams, I need to put grams on bottom and moles on top. This number is attached to the G, so I'd write it next to the G. 18 grams per mole means 18 grams per every 1 mole. And now it's 55 divided by 18, which is 3.052 964 grams. Cancel each other out, giving me just moles left. What do you mean? That's one number. That's scientific notation. So this is the same. So this is the same thing as 5.5 times 10 to the 1. So I can replace this as 5.5 times 10 to the 1. I just do it the same thing. I plug this in the calculator. 5.5 times 10 to the 1 divided by 18.01528, and that's equal to 3.052964 moles. That's just another way of writing a number. 55 is equal to this number. Alright, so we're going to have a test tomorrow. So let's review for the test. So you need to know how to find molar mass. So I asked you to find, for example, what is the molar mass of H2O? Or let me make a better chemical. Where's my periodic table? Alright, so let's look at aluminum carbonate. So what is the molar mass of aluminum carbonate? So this formula is Al2CO33. So there are 2 aluminums. This 3 on the parentheses tells us we need to multiply everything inside. So that'll be 3 carbon. And there'll be 9 oxygen. So we look at the periodic table. That'd be 2 times 26.981538. That'll be 3 times 12.0107. And that'll be 9 times 15.9994. Yes, you can look at the periodic table. It's for aluminum. By the way, we're using the periodic table a lot. You should always have it handy. And the units is grams per mole. So it's 26.981538. So know how to figure out molar mass. This test also has significant figures on it. And this will be the last test where I do significant figures. At least I believe it's the last test. Know how to convert between atoms or molecules or particles or whatever to moles, and vice versa. Moles to atoms, molecules, particles, whatever. We know that 1 mole of something is equal to 6.022 times 10 to the 23 of whatever that unit is. So units. So this unit could be atoms, it could be molecules or whatever. So if I ask you how many atoms are in 1 mole, that's 6.022 times 10 to the 23. To do it, you would, so if I asked you in 1 mole, well, let's do 2 moles. So in 2 moles, how many atoms are there? We set up our conversion factor. We need to cancel out moles, so we put moles on bottom, and we put atoms on top, so that moles cancel each other out. We know that there are 6.022 times 10 to the 23 atoms in 1 mole. Moles cancel out, giving us just atoms, so we multiply these together. And that's 1.2044 times 10 to the 24. And it'd be atoms because that's the only unit left. Ten to the 24. Yes, between moles and atoms, are atoms to moles. We plug in, this is our conversion factor. We get this from this. And we put atoms or moles on top or bottom, depending on what we started with. We want to cancel out moles, we want moles on bottom. So if we give how many is 5 times 10 to the 10 atoms, how many moles is that? Well, we know we need atoms on the bottom and moles on the top, so that the atoms will cancel out. We know that there are 6.022 times 10 to the 23 atoms for every 1 mole. So we divide, and we get 8.3 times 10 to the negative 14, and atoms cancel out, giving us just moles. So let's do another example. So if I'm converting, so let's do 55 centimeters. And I'm trying to convert centimeters into meters. What unit would go here and what unit would go here? So centimeters on the bottom, and up here, meters. So you should recognize that there are 100 centimeters in 1 meter. There is 1,000 millimeters in 1 meter. There are for 1 kilometer, there is 1,000 meters. We will be using the metric system quite a lot. You should have these ratios somewhat memorized so that you can convert everything back into meters. How many significant figures does that have? It would be 4. What about that one? What about that one? 7. What about that one? Even though this is slightly improper, what about that one? If there's a period, you include trailing zeros. That's why I said this is slightly improper. Technically, according to the rules, this is valid and would be 4, but I don't like ever seeing this. If you want 4 significant digits, you do 5.500 times 10 to the 3. This is the preferred way of writing it with 4 significant digits. Technically, you could do it like that, but this is improper because you're right. You shouldn't have a period because you can't tell if it's at the end of the sentence. So this is slightly improper. You would really convert it into scientific notation. So if I wanted to convert 800 kilometers into meters, how would you do it? How would you set it up? So 1 kilometer will go on the bottom, and 1,000 meters will go on the top. Unfortunately, I cannot make this grid on the test, so it's going to look like this on the test. It'll be looking like there is, though, you can see there's nothing here, and it looks like this. I just can't make this vertical line and a horizontal line that's the end of everything. But you can clearly fill in the missing grid if you want to. So you go to school 8 hours a day. How many hours in 2 weeks? And I would say that you go to school 8 hours a day, 5 days a week. Over the course of 2 weeks, how many hours are you at school? So setting it up using dimensional analysis. Again, on the test is multiple choice this go around. So I don't care how you get the answer, as long as you get an answer and circle it correctly. So it's 8 hours per day. That's what we're given. We're given that you go to school 8 hours. No, it's asking for 2 weeks. So it's giving you 2 weeks. And it's asking you to convert 2 weeks into hours. We know that there's a ratio of 5 days a week. So I can put week on bottom, day on top, and I know it's 5 days for every 1 week. So weeks cancel out, I'm now in days. I can convert days and hours. So I put day on bottom, hours on top. So 8 hours for 1 day. Days cancel out, now I'm in hours. So it's simply 2 times 5 times 8. I haven't done it yet. So 80 hours. Oh, yeah. I'm recording a video. Can we do it later? I'll do it like as soon as the class period is over. This is, So this is dimensional analysis. You find ratios and conversions. We're given in a weeks, and we see how can we convert weeks. We can convert weeks into days, So we add this 5 days a week conversion factor in. We add it in right here. It's 5 days, so we put the 5 with the days. A week is just a single week, so it'd be 1 week. We have a conversion, so now we can cross out weeks, and we're in days. We can convert days into hours using this conversion factor. And you just keep doing this over and over again until we get into the unit we're trying to solve for. It says how many hours, so we're trying to solve for hours. So we keep adding conversion factors until we get the unit we want. So let's do a physics problem. How far will you travel in 3 hours if your speed is 50 miles per hour? Yes, these numbers and things is simple. You know that you are going 50 miles per hour, so 50 miles for 3 hours, you just multiply it's 150. It should be very obvious from this system. You just multiply the two numbers together because you're going 50 miles per hour. It was a total of 3 hours, so that'd be 50, 50, and 50. But there's a reason why I do dimensional analysis, because right now it's simple. These dimensional analysis problems aren't that complicated. Later in the year, they're going to get somewhat very advanced. So we're given 3 hours, and we need to figure out some way of converting hours into miles. This statement right here tells you there are 50 miles per every hour. We have hours here, so we need to put hours on the bottom, and we can put miles on the top. So this 50 miles can be plugged in as a conversion factor. 50 miles, the 50 is attached to the M, so we put 50 on top. And it's per hour, so that means per every single hour. And so it's 3 times 50, hours cancel out, and we get 150 miles. So what is atomic mass? So it's the mass of a single atom or molecule. So we can have an atomic mass for water. It would be the mass of all the individual atoms added together. What's the units we use? AMUs. And what does AMU stand for? Atomic mass unit. Not very imaginative. What is molar mass? Mass of a single mole of atoms or molecules. So atomic mass deals with counting the mass of the individual atoms. Molar mass figures out the mass of the moles of the atoms or molecules. And even though we call this molar mass, it's technically a ratio of grams to moles. We put the units as grams per mole. We don't really treat this as a mass, we treat this as a conversion ratio. $20. Avogadro's number. Memorize it. 6.022 times 10 to the 23. I want it to that level of precision. 6.022 times 10 to the 23. We will use that number quite a bit in this class. It's very important that you can be able to recall that number at any time to convert between moles and grams. If you were here in class yesterday, we had a lab. We measured out moles of, we did a quarter of a mole of water versus a quarter of a mole of sugar versus a quarter of a mole of cornstarch. So we got a 1-to-1-to-1 ratio of various chemicals. And if you were actually doing chemistry, if you were actually mixing together chemicals, that's literally what you would do in the lab. You bring a calculator, some scratch paper, and you sit here, you figure out the chemical equation, and you go, okay, I need one of that and two of those. 2 molecules of this for every 1 molecule of that. You pull out the periodic table, figure out the molar mass, convert between moles. So you need 1 mole of this to every 2 moles of that. Figure out the correct mass ratios, and you can get a ratio in terms of grams. There are like 2 or 3 density problems. So, what is the equation for density? Mass divided by volume. The importance of those questions is mostly just significant figures. In fact, all the answers are the same number with various degrees of significant figures. And also scientific notation. So scientific notation. Is this scientific notation? Is it? What's wrong with it? You always only have 1 digit followed by a decimal point. Or at the very minimum, just 1 digit. 10 times 10 to the second power is wrong. This should be written as 1.0 times 10 to the 3. Again, I'm moving the decimal over by 1, so this increases by 1. Or I could have wrote this as 0.1 times 10 to that's 100. So 10 times. So 10 times 10 to the second is 1,000. So yeah, this would be to the 4th. Because I'm moving it over again by 1. So this is wrong too. You do not write scientific notation because scientific notation is always going to be some number. It could either be some single digit, so only 1 digit, times 10 to the whatever, or it will be some digit with a period and some more digits, times 10 to the whatever. You never will have in scientific notation 2 digits with a period. So never have 2 digits in a period, times 10 to the whatever. And you'll never begin with 0 point some digit, times 10 to the whatever. It's always going to look something like 5 times 10 to the 3, or it will be 1.23 times 10 to the 3. It's always going to be at most 1 digit, like that. You can have a decimal after it. Alright, so let's suppose that we wanted to convert. So, how many atoms, how many molecules are in 1 gram of water? How many molecules are in 1 gram of water? So this is what we're given, and we're trying to convert into molecules. So we begin by what we're given. This is a conversion factor. It's a nominal value. So we need to ask, what are our conversion factors? We know molar mass converts grams into moles, and we know that Avogadro's number converts moles into molecules. So first we're going to need to convert into moles. So we only have 2 conversion factors. We have grams to moles and moles to molecules. So I know that I need to first have a G on bottom to cancel it out, and I can only convert into molecules initially. Again, because I'm using water quite a bit, we know that the molar mass of water is 18.01528. You get this by adding up 2 hydrogen and 1 oxygen masses. And this is 18 grams per 1 mole. So I cancel out grams, and now I'm in moles. So currently I am in moles. I want to be in molecules. So I know it's going to be a mole on bottom and a molecule on top, so that moles cancel out. I know that there are exactly 6.022, or approximately 6.022 times 10 to the 23 molecules in every mole. Moles cancel out, and I'm left in molecules. So this would be equal to the 1 gram times 6.022 times 10 to the 23 divided by 18.01528. Again, you can ignore ones, because 1 times anything or 1 divided by 1 doesn't affect the equation. And I get that there are 3.3427 2 times 10 to the 22nd molecules. 6 times 10 to the 23 divided by 18. Yeah. So when you plug this into the calculator, your calculator will spit out this. Your calculator will spit out 3.3427, and the E stands for 10 to the times 10, and what comes after it is the 22. No, you put times 10. Oh, but if you're typing it into the calculator, you can use E to type it in. That's what I use. What? Are you asking about typing it in or running your answer? So in your calculator, so I have this number 6.022 times 10 to the 23. So I have this number and I have this number. When you type into the calculator, you can hit the button EE and you can plug in this number 6.022 E23. Yes. So if you're using this calculator, here is EE. So on the comma, here's EE. You can then hit, it's blue, so you press second, and then you press EE, and it pops it up. You don't have to do that. You could have typed in 6. If you're using scientific notation, always use parentheses. You could do 10 to the 23, move over, close parentheses, divided by 18.01528, and it gives you the exact same thing. If you use the E, you don't have to use parentheses, though. That's the reason why I do it, because I don't have to use parentheses. Because if I do 1 divided by 10, alright, if I did 1 divided by 2 times 10 to the 0, no, let's make this 1. 10 to the first. I can do 1 divided by 2E1, and that's equal to 0.05. I can do 1 divided by 2 times 10 to the second, and notice that does not equal 0.05, because I should have put that in parentheses. And I hate the fact that this calculator is different than mine. I need to put the parentheses down below. Alright. First of all, that's supposed to be a 1 up there. So here you can see the various ways of typing it in. This is wrong if you use scientific notation, and that should be a 1, 2 for me showing it. But still. If you're using Google, you can do 1 divided by 2E1. You could type this into Google, and it would pop out 0.05. Google recognizes E2. But if you type in 2 times 10 to the 1, make sure you type in with parentheses 2 times 10 to the 1. so that it does this first, because this is supposed to represent a single number. Have y'all's homework turned in tomorrow? I would have liked it turned in today. Nope, thank you. If y'all don't see me do the keyword, could y'all please remind me? Only if you can bring it back in the very beginning. That's the keyword. This is the keyword of the day. Like, but next morning. Yes. Write your name by the lamp on the. I usually get here by 7:15. And your calculator number. Yeah. Yeah, you can write it down. Yeah.